We are in Algebra 1, Lesson 7-2, Properties of Exponents. Now we're doing the quotient rule. Evan, what are we doing today? What's our objective?
Use quotient rule in conjunction with all previous properties of exponents.
Yep, so we're adding in one new spice to our soup, and we're going to stir it and make sure you know all the other ones. So here's the rationale behind quotient rule. If you have something like x to the power of 5 and x to the power of 3, really what you have is x to the power of 5 is x times x times x times x times x. You have 5 of those x's. Remember, whenever I have a power of 5, that is a speed sheet shortcut of how to multiply repeatedly 5 times. And then same thing down here for power of 3. If this is the power of 3, this is x times x times x. And I'm going to cross cancel. So if I cross cancel, these two are gone, these two are gone, and these two are gone, which means I'm left with an x times an x, which is just an x to the power of 2, which is interesting because I had a 5 here and a 3 here, and I'm left with a 2 here. So who can tell me in their own words, if I have an x to the power of a and an x to the power of b, what is our shortcut? I see one hand, only one hand, 2 hands? Come on, I want like all of our hands up. What's our shortcut if I have a and b? Obviously, I divide them. 5 divided by 3, right? No. Go for it, Eli. Phone a friend, Eli. You tell us.
A minus 5.
A minus 5. Always just minus 5?
I mean B.
Oh, A minus B. Yes, it is indeed. A minus B. That is our speed sheet formula, our definition that we're going to be going off of. Okay, so here are all previous definitions. Let's get a review of every single one of them, jump through some examples, and then we can start doing some individual or group work. All right, anything to the power of 0 is always, you shout out 1. Good. If you shout out 0, then you're like some people, but that's okay. It is 1. Okay, if I have a negative power, this is not a shout out. This is more of an individual question. Who knows this one? Anything to a negative power flips it. So if I flip it, it's now 1 over x to the power of positive a. Very good. What if it was already flipped and I have a negative power? Someone other than Valentina and Zane, because I forgot to do participation cards. Felipe is talking over here. He clearly wants to do it. Yeah, go for it. Flip again, and it's going to be over 1, which we're going to not write, and this is going to be x to the power of, not negative a, but positive a, exactly. So essentially, what I can boil down these two rules to say is they're the flip rules, right? Flip if negative power. And this is one that we learned yesterday as well. If I have a power of a and a power of b, and they're multiplying the bases, I've got like 3 people to choose from now. Melanie, go for it. Add the power. So this is x to the power of a plus b. And then the new one, let's get Evan in here. Go for it, Evan. A minus b, which kind of makes sense, right? If I multiply, I add. The inverse operation of multiply is to divide, and therefore we subtract. Everything is making sense so far. All right, so we're going to go around the room. We'll start with Eli, and then we're just going to circle around, make sure that everyone participates here. If I have a negative 8 to the power of 6 and negative 8 to the power of 3, this is really what? The negatives do not cancel out because you keep the base. The base does not change. It's always a negative 8. But now this negative 8 is to the power of 3, again, because you don't divide. Some people say, 6 divided by 3 is 2. No, you always subtract 6 minus 3 to get 3. Done. You leave it like this. Yes, you could say 8 to the power of 3, where's our 8 cubed up there, is 512. Just leave it like this for all of this unit, right? All right, next we're on Valentina, and then Evan's going to be doing part C. Valentina, what do we got?
To the power of 10.
It is 10. How did you get 10?
Because it's
2 negatives, so 4 minus a negative 6, which is, 2 to the power of 10. Very nice, very nice. All right, moving on to Evan.
3 to the power of 10.
I'm careful here. So in this case, we had 4 minus, the minus sign was the division, and then the negative 6, right? This one is going to be, I'm going to rewrite the negative 2 for you. Keep telling me what to write in the exponent.
Wait, is it 6?
It's negative 2, and then what does the division sign mean?
Minus
minus, and then you just rewrite that number down there, right? Minus 8. Oh, what is negative 2 minus 8? I'm already at negative 2, and then I go down 8 even more.
-10.
Negative 10. Oh, but I'm not allowed to have negative powers, so I need to do what to it?
Flip it.
Flip it. 1 over 3 to the power of
10.
positive 10. There it is. Moving on. We are on to, let's give this one to Felipe, and then we'll give Melly B and Zane, you get part C. All right. So Felipe, first thing that I see, 6 and 3. That can divide into 2. All right. Easy peasy. What about these x's? Do I divide 24 by 8 and I get 3?
And no,
I get
you have to subtract.
subtract, yes.
Yeah. That's, 16.
Very good, 16. And technically there is nothing on the bottom anymore, so some people can write divided by 1, but it's more simplified to just say 2x to the power of 16. Don't write divided by 1 anymore. All right. We're moving on to Melly, and then Zane gets the really hard one.
Should we flip it first?
You only flip if you see any negative powers. I don't see any negatives yet.
Oh.
Let's do the simplifying of this fraction. 4 and 12. We can simplify that by dividing the top and bottom by
4.
divide by 4, and it turns into
V13 divided by 3, V14.
okay, good. So all these coefficients have been simplified. Now let's deal with these v's. What's going to happen here?
It's going to be a -1.
It is going to be v to the negative 1 all over
V, no, 1.
just the
3v.
3 stays behind, right? These v's right here turn into this v right here. And then the 3 goes left over. And then, oh, can't have a negative power. Therefore, I flip it. And then what's my final answer going to be? 3 over v like that?
Or no, 1. Positive 1.
What's positive 1?
The power.
Oh, yeah. So positive 1. So this is close. The problem with the negative power is you only flip the thing that has the negative. This v has the power to come down here because we're fueled by the power of negative powers. This 3 is still stuck in the bottom. So I'm going to go ahead and say this 3 is stuck in the bottom. What's left over on the top? Anyone? It is 1. Yeah. So whenever you have nothing left over on the top, you say it's a 1. And it's more simplified to not write this power of 1 and just say it's 1 over 3v. Feeling good about that one? Doing okay? All right. And then the truly hardest of them all. Well, I guess we have some more down there. But out of the 3 sets, what are we going to do with the 3 and 39 here, Zane?
Divide
By
3.
okay, divide top by 3, divide the bottom by 3, and this is going to turn into
13.
which is 13, top or bottom?
The bottom.
The bottom is 13. The top turned into a 1, so we're not going to write the 1. What happens with those C's, the 11s?
Is it just C?
C, you just C on the top?
Yeah.
Close. When I have 11, the division here means I subtract. So I really have 11 minus 11, which is what? Here, let me move things over a little bit. Here's a fraction there. So it's c to the power of 0 over 13, which is anything to the power of 0 is.
1.
So this is equal to 1 over 13. Done. Another quick way of doing this, if any of you want a shortcut, is anytime you see the same thing on the top and the bottom, ooh, look, a c to the power of 11, a c to the power of 11, those are the same thing, just cross them off. Because that's essentially what we did. And then we had the 1 over 13 left over behind. Cool. And the rationale here is now you see, oh, it was because it was a power of 0. All right. These are more the hard ones. These are the ones that are most likely to show up on a quiz or a test. These, I'm going to ask for a volunteer because they're tricky. I just need one step. So Valentina, you get to do either the A's, the B's, or the coefficients. What do you want to do?
The 8.
The A's. All right. What are you seeing?
Multiply 5a into
Yeah, well, those are the coefficients. Let's just do this A, and that A. That's kind of the 3 that I'm seeing, right? You want me to make this? All right, there you go.
2a to the power of 3.
2a to the power of 3. Well, let's not do the coefficients quite yet. Let's just do the a's. So I have an a to the power of, this is a power of 0, power of -3, and power of, what's that one? 1? Okay, I'm going to put a 1 down here so I can remember. If you don't see a power, we assume that power is 1. And then what's the number that goes up here for our power of a? How'd you get positive 3?
0 minus
We don't, whenever I have multiplication here, this is now a review of rules. I don't subtract, I add. So this is going to be 0 plus the -3. And then what do I do with that 1 down here? I subtract the 1. So it's going to be a to the -4. So I'm going to come down here and write a to the -4. Okay. Valentina did all the a's for us. I need someone to either do the coefficients or the b's now. Evan, what do you want to do? You'll do the b's. All right. So I have a b, and a b. What is this power right here, Evan? Okay, it's power of 1. Maybe I should do this in a different color. I'll say power of 1. So b is going to be on the top, and it's going to be the power of what then? 1 plus 2. And then what do I do with this one? -3. Okay, what does that turn into? B to the power of? 0. Oh, 0. Interesting. And anything to the power of 0? Yeah, so it's 1. So it just, we cross it off, right? Okay, that means I need someone to do the coefficients, the 5, the 2, and the 10 here. Who's it gonna be? Everyone has participated quite a bit. Melly, yeah, go for it.
5 times 2, 10.
Okay. And
Divided by 10.
that's all divided by 10. So what's going to happen with that 10 and that 10?
Stay the same?
They cancel. Yeah, if they're the same on the top, same on the bottom, they cancel out, which means they're just gone. And that means that literally my final answer is going to be a to the -4, but it's a negative power. So someone other than the 3 that have already participated on this problem, tell me exactly what to write, Felipe.
1 divided by a maybe 4. No, a4.
A to the power 4, yeah. There's our final answer on that one. A lot of work required, but we got it in the end. All right. And then this truly scary thing. We're going to start off with Eli and Zane. One of you two first, because you didn't participate in the last problem. Which of you wants to do? You can do the x's, the y's, the coefficients. All right. Zane calls coefficients. He calls dibs. I'm seeing a 4, a 2, and a 6. Those are the numbers out front. Oh, there's no coefficient here. So what, you're going to have to deal with that. I don't know what to do. You're going to tell me. Yeah, you do. Okay, so we're going to say, okay, 4 times 2, that's going to be an 8 out there. The 6 is still, is it 6 on the bottom, or what happens with not having one? Is that a 0 or a 1? It's a 1, so 6 times 1, we can just say 6. Okay, Zane's got the coefficients. What is that eventually going to do? 8 and 6, are they done? Can it simplify anymore?
No.
What could I do?
Divide both of them by 2.
Divide by 2, divide by 2, and that's going to turn into
4 over 3.
Okay, so coefficients are now done. They're locked in. 4 and 3, they can't move. I can't flip them because they don't have any negative powers. 4 and 3 are going to be in the answer. All right. Eli, you got to choose either the x's or the y's, and I'll choose some random person to do the letter that you don't want to do. He's doing the y's. All right, so we got 4 of them. What power goes here? 1. Okay, so let's do the y's here. I have y to the power of what? You can show all of your work. Let's go ahead and add and subtract whatever we're supposed to do.
Plus 2 minus 0. Minus 5.
Yeah, that's a great way to think about it. I'm going to write my 5s a little bit nicer. Yeah, this was a minus because on the bottom, minus because on the bottom. I mean, technically it's a power of 0, so I didn't even have to do it. But if you can write minus 0, it's the same thing as not doing it, right? All right, what does the y turn into? What does this power simplify to? It turns into a -2. And that means what's going to happen because I have a negative power? It's going to go to the bottom, so I'm going to have my fraction right here, y to the power of 2. I still have Zane's original 4. Oop, I want to do that in black. 4 and 3. I have no idea what's happening with the x's yet, but I think the y's are all done. Who wants to do the x's? Evan, go for it. So I see a power there. Oh, I don't see a power there. What power should we really have right there?
1.
So power of 1. See a power there. I see a power there. Okay. Yeah. Tell me what to do with the x's now. I have x to the power of.
1.
Let me move this over a little bit because I realize I'm going to write 1.
And then minus 3. Minus negative.
Very good. Minus a negative 2. We do have a double negative happening down here. So that's going to turn into an x to the power of what?
4.
4. How did you get 4? Walk me through it.
So you do. Wait, is that negative 3?
It is 1 minus 3. That's what you told me to write. What's 1 minus 3?
Negative 2.
I'll write it down first. I have a negative 2. And then when I have double negatives, they kiss and become positive, right?
0.
Yeah, it's going to be x to the power of 0. This whole thing will say this whole thing went to 0. And anything to the power of 0 is 1, which means we cross it off. And there's our final answer. It doesn't look super nice, but we can say that's our final answer. It's 4 over 3y squared. All right. So those are kind of hard examples, but we'll get some more practice today. Fist of 5, how well can you use the quotient rule in conjunction with all of our previous rules? How well can you do example 3, right? I'm seeing a 4, a 5, a 4, a 5, a 4, and a 3.5. All right, thanks.